Okay, it's 1 o'clock, so let's get started. Today we're going to talk about inheritance in Python. It's a little crazy, but it's really fun. You can do some really cool things. First, I just want to note, has anyone started on homework 2, or homework 1, I guess, the second homework? Okay, good, because I just made changes last night. So if you cloned the repo, pull it, because you're going to want the updated version of the homework. Who submitted the prisoner? Okay, a good number. It's totally fine if you didn't, because I realized in retrospect that some of the instructions were not very good. So I'm going to have to improve the instructions for the next homework before the next homework is actually assigned. I realize that now. So totally fine. There's a late policy. It's like 20% per week or something, but it's fine because it's just 60% to pass, so don't worry. So yeah, we're going to talk about Python inheritance. I'll do this later, but let's watch the prisoners. Is Spencer Martin in the room?
Hi.
Yeah? All right. Man, I spent hours dealing with your code. How did you learn reflection?
Oh, I just figured, why not investigate stack frames above me? And so
Yeah.
I
All right. All right. Well, just wait till we get to that unit, please. This guy used a later metaprogramming topic to basically hack my system. And yeah, I'm going to have to squash that, just so you know. Because it relies on the operating system module, and I block you from importing the operating system module. So but inspect imports OS.
Oh, that's it?
Yeah. So I'll try running it, but if it crashes, then I'm just going to have to squash it. But anyway, let's see. This might error. I was frantically trying to fix all the errors just now. The problem is, if I can't, I wrote the runner, and you guys have a runner on GitHub. That's not the runner I'm going to run, because it occurred to me that if a single file has a single error in it, the whole runner is just going to crash. So I had to surround everything in try-catch, and it was a big pain, and block the operating system and inspect. So we'll see if all of that actually worked. All right, so this is without blocking inspect. -1 means there was an error in your file, so don't worry about it. I'll give you credit if you just submit anything at all. But the -1 means that there is some runtime error. And then hypnotist is Spencer's. Spencer's prisoner is hypnotist, and everybody else loses. Because, like I said, he hacked my system. Do you want to know what Spencer's... Do you want to explain what your prisoner does?
Yeah, sure. So because you were so kind as to go and upload your tester,
Yeah.
to go figure out where to store all of your prisoners, and so I just made it so that all of your prisoners didn't rat on me, and I would rat on you guys.
Yeah. Yeah. Yeah, no, his prisoner looks up the stack trace, finds my variable where I stored everybody's prisoners, and then loops through it and changes your decide method to return false. So obviously, you win, but I'm gonna block you here. Block. And so blocking, it's JRF. Oh, we've got a tie. A tie between JR6FF and AFJ3VH. Okay, one. Who's the other? Yeah? Andrew?
Mine doesn't work in this one, but it worked in the last one.
Oh, it did?
Yeah, me as well.
Then you must have imported OS or system.
I imported random.
Random?
Yeah, me too.
Oh, you imported random too?
Yeah.
All right, well, so this is what I'm saying. I should have posted my actual tester probably, because I have to block you from importing OS because otherwise you could crash my computer. So just be careful with imports, I guess. But so we've got Spencer, JRF, who's? That's you, and then the other person, AFJ. Okay, I've got prizes as promised. So, Spencer, take your pick. We got M&M's, Hershey's, and Kit Kat. All right, what do you want? All right. You guys want to say your strategy? Uh-huh.
Copy whatever they did.
Yep.
After that, but then if they like confessed on me twice in a row, then I'd always confess on them. And I don't know. I think in the thing you posted there were 100 runs.
Yeah.
So I counted until it was 100, then I just confessed on that.
Oh, nice. Get that last punch in there before they can. That's a good call. Yeah, the optimal strategy is called tit for tat, which basically says that you do whatever your opponent did to you last. That's been shown to be almost very close to optimal. So that sounds like pretty much what you did, except you threw in a punch at the end. Yeah, cool. All right, so that was fun. Like I said, I tried to put a little bit more thought into this next homework, so hopefully there will be fewer issues. I also realized who on Windows had issues running the file. Okay. Just one person? Okay. Well, I totally forgot that Windows is a thing. So I'll try to be a little bit more OS independent in the future.
Mine errors up there, but I just sort of hit your tester with a hammer a bunch, and I can get my prisoner to run on my machine.
Yeah. No, like I said, I'm going to give you credit whether it runs or not. But okay. So yeah, last week we talked about the ubiquity of objects, dynamic typing, assertions, warnings. We talked about the class, self, init, which is the constructor, dunder, new versus init. Is all this coming back? We've got classes. Yeah. So now today we're going to talk about inheritance, which is pretty cool. I'm on this computer. Okay. Just a quick note, if you're running Python 2, some of this won't apply. So I recommend that you run Python 3, basically. Python 3 switches to new style classes. So just if something isn't working, just know that it only works on Python 3. Okay, so the syntax of inheritance in Python is super simple. Let's say we've got a person class, the classic person class, and we've got a name field, a string method, and if we print out a person, we get what we expect. Now, if we want to inherit from person, we just put the class that we're inheriting in parentheses after the name of the class. So the superclass goes there, and this means student is a person. So we can override the init method. But then if we want to call the super init method, we call super, and then we call whatever method we want to call on super. We can add our own methods. So report is just going to return the ID. And if we print a student, we get the super string method. But if we print the report, we get the computing ID. So does that make sense? Pretty straightforward. One thing to note is that everything inherits from object. And so we can optionally put object in parentheses for any class that just inherits from object. This is one of the differences between Python 1 and Python 2. Python 2 and 3. In Python 2, you have to do this. In Python 3, it's optional. And then another thing to note is here we accessed the super init by calling super and then calling init. Another way to do this is to explicitly reference the superclass. So here we have class student inherits from person, but now we're calling the super init by just referencing person directly. But one thing to note is that when we do this, we're calling init statically, which means that we have to pass self in manually. And if that doesn't make sense, that's OK, because usually we just use super. But it's good to know that you can do this. Any method in Python can be called statically or non-statically. And so this is an example of init being called non-statically and init being called statically. Yeah. So let's just practice by implementing some inheritance, right? This is the diagram we'll implement. Let's start with this half. We've got class A inherits from object. Class C inherits from A. Class D inherits from A. Class E, etc. And now, if we want to check the superclass of a certain class, we just access the bases attribute. And this stands for base classes or superclasses, just synonyms. So here, if we get the base classes of C, what do we expect? A, yeah. So we get A. And some other stuff, but basically A. Let's do the other half. We've got exception, my exception. Exception is built in. So we just have to write my exception, which inherits from exception. We have an init method, which can take in a message if you want. This is basically the same as Java overriding exceptions. You can write your own constructor and take in a message and then call the super constructor with that message. And then we're also going to print one exceptional exception. And now if we do this, we can raise my exception, pass in the message. We get one exceptional exception, and then an error report. Does that make sense? Pretty straightforward. Basically the same as Java and any other programming language you know. For now. But I want to go ahead and introduce this concept of the method resolution order, or the MRO. And what this refers to is the fact that if we have an instance of a given class and we call a method on that instance, we need to find an implementation of that method to call. So, like, let's say class A here has a foo method, and D does not have a foo method, but it inherits from A, so that's OK. If we call foo on an instance of D, we need to find the implementation in A in order to actually call the function. So with that in mind, suppose we call foo on an instance of C. We need to find a version of foo to call. Where do we look first? In C, right? Yeah. If there's a foo method in C, we want to call that one because it's overridden every other foo method. So we look in C first. Then where? A, yep. And then object. So from this picture here, what does it look like the MRO algorithm is?
It just comes up the tree.
Yeah, it just goes up the tree.
What if you had like multiple inheritance, like C inherited from
Oh.
A and some
Oh, I'll get to it. Yeah, this is kind of the naive MRO, just go up the tree. Because, like you said, if we have multiple inheritance, this is no longer a tree. Yeah, you totally beat my segue. This was supposed to be a segue into multiple inheritance. Multiple inheritance. I had this whole segues planned out, whatever.
You still get it.
Okay, so just like before, we had a diagram, we implemented it. Let's just try implementing this, right? It doesn't look too hard. I bet you can already guess how it's going to go. Like, we've got class A inherits from object, B inherits from object, C inherits from A and B. So you just comma separate the multiple superclasses. And that's all there is to it. You're doing multiple inheritance. We've got D inherits from B and A. Now you might be asking, does this make a difference? Does the order make a difference? Well, yes, and we'll get to that later. And then we've got class E inherits from C and D. And if we wanted to check the base classes of E, what did we expect? Well, the base classes are considered only the direct superclasses. So we would just get C and D, right? This doesn't compile. It turns out that actually the moment we declare this class, we'll get a compilation error. So that's pretty weird. Let's investigate. Let's do that MRO thing again. Suppose we call foo on an E, on an instance of E. Where do we look first? E, yep. Then where?
Where's the last C class?
C? C and D? Well, we have to check one first.
I would think you would. Okay, I mean, you just have to pick one.
Yeah?
I would say it's in the order that you pass them into the things. You said
Yes.
it mattered.
Yep. Yeah, it goes in the order that you pass the superclasses into the class definitions. So here we said E inherits from C and then D. So C is checked first. So we're starting to see an algorithm form here, right? We want to check in the order that it's declared. So we check E, then we check C or D, we check C, and then A, B, or D. D, A, B, A, or D.
Well, we don't have any indication of like where foo actually lives, so we don't have any reason to like follow the path from C down versus going back to the earlier heading in D.
Yeah, we can't know. We can't know where foo actually is.
Yeah.
So basically, it's really ambiguous, right? You could make an argument for A. You could make an argument for D. B, probably not, but basically, we need a better algorithm. We need a way to deterministically figure out exactly where we're going to check for the method. And that algorithm is called C3 Linearization. So if you've taken algorithms, put your algorithm cap on, because we're about to go over an algorithm. And I've tried to do this in the most Brunel colorful way, so if you've had Brunel. So we need to compute the linearization of a class. So linearization, represented by the red L, is a function that takes in a class and outputs its linearization, or the order that we're going to check the superclasses. Some definitions here. Let the head of a list be the first element. Oh, also, you don't have to memorize this, but you should understand it because it's going to come up in the homework, if you do the homework the right way. Let the tail of the list be everything after the first element. So we've got the head, and then everything else the tail. Let merge of a sequence of lists, so this is merge of several lists, be the following algorithm. Find the head, the first head, that is not in the tail of any other list. Append it to the output, and remove it from all of the inputs. Okay? You'll notice that I'm saying absolutely nothing about how I would actually implement this algorithm. It's really complicated. You'd need a lot of divide and conquer and dynamic programming in order to actually make this efficient. But it is possible to make it efficient. And this is actually what Python does. So repeat until all the input lists are empty. So this is the merge of several lists. Does everybody understand that? At least on a high level? OK. All right, and this is it. This is the linearization algorithm. The linearization of class X is the list containing the class itself, right? We want to check the class first, right? So we check that class first, plus the merge of the linearization of all of the superclasses and the superclasses themselves. So this is a recursive function. And so, like I said, you'd need a lot of dynamic programming to actually make this efficient, but it is possible. So what's the linearization of object? Just object, yeah. Because we've got the class itself and then the merge of nothing. So how about the linearization of B? B, an object, yeah. We've got the class itself and then the merge of the linearization of object and object, which just reduces to object. Okay, how about the linearization of C? Well, let's think. Let's write out the definition. We've got the merge of L of A, L of B, and A and B. So the merge of L of A, L of B, and A and B. The linearization of A is what? A object. Linearization of B is B object, and then AB. So we find the first head that is not in the tail of any other list. Is A in the tail of any list? No. So we append that to the output. So we've got the out equals A. And then we remove A from all of the inputs. Okay? Now, we find the first head that is not in the tail of any other list. Is object in the tail of any other list? Yes. Is B in the tail of any other list? No, because we removed A. So now B is the head of this list. So we add B to the output, and remove it from all the inputs. And now what are we left with? Object. So A, B, oh, plus C. But this is the merge. And so the linearization is C plus that. Does that make sense? So C, A, B object. So this is nice. We've got an algorithm. Now we know for sure exactly where to check for the next method. Linearization of D. It's very similar to what we just did. We've got the linearization of B and A, which is B object, A object, and then B, A, which reduces down to, any guesses?
DBA object.
DBA object, yep. All right. Now, how about the linearization of E? We've got E plus the merge of the linearization of C. Yeah. So what was the linearization of C? C, A, B object. All right, and the linearization of D. What's the linearization of D? And then finally, the superclasses themselves, which are C and D. Did I do that right? Yeah? Okay. So let's do the merge algorithm, right? So is C in the tail of any other list? No. So we append it. Then remove it. All right, is A in the tail of any other list? Yes. Is D in the tail of any other list? No. Okay. Is A in the tail of any other list? Yes. Is B in the tail of any other list?
Yes.
Yes. So this algorithm fails. There is no head of any list here that is not the tail in the tail of another list. So merge fails. So what does that mean for our algorithm?
It's bad.
Yeah, it means, well, it's not a bad algorithm. It just means that there is no linearization for this class structure. So, and this is that scenario. So let's say that we declared all the other classes, and now we're finally declaring E, which subclasses C and D, pass, enter, error. You'll immediately get an error. You cannot declare that class. That class cannot exist because it's ambiguous. There's no method resolution order for that class. Pretty cool, huh? Yeah? All right. So yeah, that's why there was a big blue X on the previous slide. It's because it won't even let us get that far. Uh-huh.
So in Java, you can only extend like one superclass. Why in Python does it let you like inherit from multiple classes?
Because it's useful. Yeah. Like let's say you have a well, let's see, what's a classic example? Let's say you have a pizza class, and you want to write as little for this pizza class as possible. Well, one way you could potentially write it is as an inheritance of dough, tomatoes, and mozzarella. So that's an actual thing that you could do in Python. You could write a dough class, a tomato class, and a mozzarella class, and then write pizza, which inherits all three. And then you might end up saving yourself a lot of work that way, because there might be methods of the tomato class like check ripeness. You could check the ripeness of your pizza automatically. You wouldn't have to copy in the ripeness method. Does that make sense? So that's why multiple inheritance is useful.
So why is C3 linearization and not some other way of integrating the parent classes?
Why C3 linearization and not some other way?
Yeah, because obviously it has this limitation that there are certain inheritance structures that are forbidden.
Yeah.
Conceivably, you can make another algorithm that would give you more flexibility.
We don't know of one. This is the best known multiple inheritance algorithm. It's actually, it's an area of research in computer science. You could go into graduate school studying this. Mm-hmm.
But couldn't you also just if C3 fails, just have a caveat, if this doesn't work, then just do A, B, C, D, just pick an order, just so you can go.
Pick an order? Because the creators of Python decided that it would be better to just not let you make ambiguous situations than to arbitrarily pick an order, because that could lead to unexpected behavior. It's better to, if the situation is truly ambiguous, then it's better to tell the developer that it's ambiguous than it is to kind of sweep it under the carpet. Does that make sense?
That makes sense.
Because you have to create also an entire another algorithm to figure out
Yeah.
what to do in those ambiguous situations.
Yep.
Because it wouldn't necessarily be this simple. It could be theoretically infinitely complicated.
Yeah. Yeah, there isn't really a clear way of how you would do that. But like I said, you could research it if you want. So anyway, this is the C3 linearization algorithm. Did that make sense to everybody? Like I said, you don't have to memorize this or anything, but you'll probably want to have these slides up for the homework. Or not, I don't know. There's actually, yeah. So there's one loose end. What about super, right? Because earlier at the beginning, I said if we want to call the super init method, then you just call super and then you call init on super. Well, what is super now? Because there's no one superclass. So what, are you calling the init method of every direct superclass, or what? How does this work? The answer is super uses the MRO, the C3 linearization. So what super actually means, and it's kind of a misnamed function. People think that it means superclass. That's not what it means. super means next in the MRO, which sometimes is your superclass, but sometimes is not, right? We saw well, I don't have the diagram memorized, so I actually can't. But the MRO of D goes DBA object. So what comes after B in the MRO? A. So that means if you call super in B, you'll actually get A. Yeah. But the problem is every class has its own MRO. As we saw, D has an MRO. The class D has an MRO. The class E doesn't have an MRO. The class B has a different. So every class has a different MRO. So which MRO are we talking about here when we say next in the MRO?
Is there a method resolution?
No. We just don't know. Basically, you can't know. Sorry?
I thought we didn't want ambiguity.
But this isn't ambiguous. Just because we don't know which MRO we're in doesn't mean that it's not deterministic. So we still know for sure that we're going to go to the next thing in the MRO. We just don't know whose MRO it is. Does that make sense? It's not like the Python compiler is just making some random ambiguous choices. It's the developer is in full control of which MRO it is. It's just when you're writing the class and you say super, you can't know at that time, unless you know exactly how the class is going to be used in the future. So let's check this out. We've got a diamond diagram. So who is B's super? A. Is it? All right, so we've got A. A has a foo method, and it's going to print A. B has a foo method, and it's going to call super. So this is how we're going to tell who B's super is, right? If A is the super, we'll expect A to be printed out. And D inherits from A. It's going to print D. And C is going to inherit from B and D. And there's nothing in C. So, all right, we make a B, and we call foo. Who thinks it's going to be A? Who thinks it's going to be D? Okay? It's A. But now, C.foo. Who thinks it's going to be A? And who thinks it's going to be D? Yeah, it's D. So basically, in both scenarios, we look for the method foo in C. Or let's see, I guess. Yeah, in this scenario here, we look for the method foo in C. And it's not there. Nothing's there. So we look at B. B does have a foo method, but it calls super. But super means next in the MRO, and we started in C. So it's next in C's MRO, which is D. So we super, in this case, actually calls out to the side and gets the sibling instead of the parent. So that's pretty cool. You might think that that's really dangerous, and it can be if you don't understand what super means. If you don't understand what super means, then yeah, it can be very dangerous. You can get very unexpected behavior. But if you know what super means and you use it knowing that, you can do some really cool things, specifically dependency injection, which is where you use this fact that you can control the MRO to actually cause things to call out to the side instead of up on purpose. Keep this in mind for the homework.
So when we did B.foo, we were accessing B's MRO, and B's MRO was just BA.
Yep.
It didn't know anything about the classes C and D at that time.
Yep. Yeah. Yeah, the super means next in the MRO of the class that we originally called on. Yeah. Okay. We're going to do group coding again. Be cool, all right? I don't want too many memes. I mean, maybe like a couple of memes in the comments, not in plain text. All right? Okay. So everybody's getting Atom up? All right, cool. Oh, it's called Divi. It's a little tool. So if I'm in a window, I have the hotkey for Divi, and it just pulls up this grid, and I can, move the window on the grid, which is really handy if you want to set up development environments like where you've got half the window here, and then you've got your terminal up here, and then you've got Finder down here.
Is it Mac only? Or?
Did you pay for that? Or?
Yeah, I paid for it. You don't mess around with your development environment. You've got to have it right, So if you got to pay for what you need, you got to pay for it. Okay, so the thing that I'm doing differently this time with group coding is that I've already made a file, all right? And there's already stuff in the file. Don't touch that stuff. Don't touch it. There's a section for you that says, add your animal here. Do whatever you want, but make an animal in that section, please, and nothing else.
Can you give us a portal?
Yeah, are you guys ready for the portal? I guess I'll email it out like I did last time, because it's a long link. Also, thanks for the anonymous feedback, guys, who sent it in. I got 4. A little disappointing, but keep it coming. Keep it coming. I get an email notification and everything, so I'm ready. I'm ready for your anonymous feedback. Did you guys get it? Yeah? Okay, cool. All right, so let me just explain what we're doing here. I want you guys to be able to practice inheritance. So I've written a base class called Animal, and I want you to extend that base class. So everybody, that's the other thing I'm doing differently. Last time, I tried to get us to all work on one class together. That's not going to work. So everybody make your own animal, and make sure you inherit from animal. And then at the end, we're going to have a big, barn chat. I'm going to hit play, and hopefully stuff will happen. So, look at this. Now, one thing you'll note is that in this animal class, I made an abstract method, greet. This just means that you must override this method. So everybody must write a greet method, and your greet method should return a string. Okay? And it takes in other, as in another animal. Another thing to note is you may override these methods if you want. You may override those. But you have to override this one. How's it going? Who's written their animal? A couple of people, okay. Lowercase c. Fish, something, cool. Polar bear. How do you pronounce that? Who's doing the chimera? Chimera? What is that?
It's the Greek monster that's like part goat.
Oh, yeah, cool. All right, that's going to be an interesting greeting. Pig, tiger. Is this fun, or is this like just super boring? Spit is on your face now. Camel, yep. Banana? Bananas are not animals. But okay. Human, Bigfoot. Oh man, my computer's working hard. Here's another thing. I mentioned in the last class that there's no cheating policy. So basically you can copy code, you can do whatever. But then it occurred to me that if you don't happen to know anyone else in the class, you don't have anyone you can cheat off of. So I want you guys to make a group chat and don't invite me, so that you guys can cheat together. So somebody who's gonna be in charge of that? All right, Will's gonna make the group chat.
All right, do people want group me or Slack? All right, we're doing group me. Slack is overrated.
Now, be aware that just because I'm not in the group chat doesn't mean I won't know what goes on. You know, I've got. No, you're not. Okay, that's my roommate. So, just be cool, cheat, but don't be hurtful.
My phone already autocorrects to metaprogramming. That's all right. Put yourself in there.
And just so you know, I am going to block inspect from now on. Yeah. Oh, one last thing. Everybody, at the very top of this file, put a comment with your name on it. That's going to be attendance. If you can't type, I can. Whoa, comments are hashtags. Hashtags.
Where's my cursor?
So you just can't type? What's happening?
It's like frozen.
Oh, it's frozen?
It takes a while to do. For me, it took a while, but eventually now.
Oh, no,
to load.
mine's like, keep waiting. It's
Oh.
force close or keep waiting.
Editor is not responding. Oh man, all right, that's tricky. I'll write down your name. All right, I don't know what this is. What's your name?
It's Devon, D-V-O-N.
D-V-O-N.
Last name Y-I.
How, sorry?
Y-I.
Y-I.
Thank you.
Okay. Do you guys know you can split your cursor in Atom?
What is it? Oh, wait, what?
Well, oh man, I didn't like that with everybody else, but here, guys, check this out. Like, let's say I want to indent this entire block. You can split your cursor
Oh my.
and indent it.
How do you do that?
It depends on if on Mac it's Control-Shift and then the down arrow key, and that'll just spawn new cursors downward. You can also hold down Command and spawn cursors wherever you click. So, yeah, pretty cool stuff.
Oh, Control just like grabs the line and moves it with your cursor.
Yeah, it's different on different computers. I might have actually had to change the hotkeys. Yeah. Uh-huh.
If you command G, it'll split to match other things that you currently do.
Really? Cool. Command G?
I think it's, yeah.
Huh. Interesting. All right.
This is why Control C is copy.
Hey, how do I enter my user
enter your phone number, and then when it says add a new number, click on that, and then enter your name.
Okay, I just don't want to make a new contact thing.
That's what you want. It's here to make friends.
No, I didn't know if GroupMe was integrated with like actual.
It's not.
All right. Does everybody think that their class is going to compile?
Yeah.
All right.
I trust you all.
I didn't do it. I don't think so.
You shouldn't need an init.
You didn't need it?
Nah. It's an optional I mean, let's see. Let's see. Oh, you guys are seeing all my secret stuff. All right, Python 3 inherit. All right. There is a compile error. So this is so. I mean.
I think you should save it and then actually manipulate it to do work.
You should kick us all off before you add.
Yeah, you should kick us all off.
If we hit Control S,
I was about to say.
we have saving power.
Yeah, only I can save it. Yeah.
Yeah. I do recommend kicking us all off and then doing it.
That's no fun. Just be cool. Somebody forgot a colon. Oh, actually, there's one right here. Don't forget a colon after your second parenthesis. Name error. Cat is not defined.
Damn it.
Polar bear?
It's capital.
Hey, polar bear? Why are you inheriting from cat, first of all?
Is bear in there already?
Polar bear. There's a capital C cat. You can do capital C cat. Or animal. Yeah, that works.
Is a bear more like a dog or more like a cat? I think it's its own thing.
I think it should be.
They climb trees. That makes them cat-like, I guess.
But there are those really big dogs that look like small bears.
This is true. Or regular sized bears.
There's those really little dogs that look like bears.
Hey, Flamingo, you named your method grief. Oh, we got a lot. Oh, man. I should have calculated how many lines this will actually print. This is way too much. Cat says meow to... That's the one I wrote. Does mayonnaise count? Mitochondrium punches you in the face with science and says, I'm the powerhouse of the cell to cat and to dog. I was kind of hoping that people would say, if other is instance of cat, then don't eat, but this is cool, too. This is cool. Tiger eats. Elephant says, I love Max. Aw, thanks, Elephant. 42, nice. Hitchhiker's Guide to the Galaxy. Who did that? Who? Yeah, nice, awesome. Shark. Dolphin says, what up? Cool. Fish says, I'm a fish. Moo. Okay. Alexa says, playing Despacito 2. Something says, who knows what I am? Kamir says, bleat, roar, hiss. All right, yeah, I guess that's what they sound like. Yeah.
It is.
My all-knowing stare. Polar bear says, I will eat you now. Hiss, snick. Turtle hides in shell if scared.
No, we did one wrong. 100%.
All right, sorry if you guys didn't show up there. I got a name error here. So, but the class is over, so.